NSPredicate is a foundation class that specifies how data should be fetched or filtered. Its query language, predicates, represent logical conditions which you can use to filter collections of objects. You use it to find CloudKit object references or when filtering core data fetch requests. I use Realm as my data store and used NSPredicate when filtering Realm collections. You'll encounter NSPredicate many times during your development career, so in this video I'd like to introduce you to NSPredicate and give you a foundation that you can apply everywhere. We'll use a variety of comparison operators and arguments with and without variable substitution. We'll use predicate options, compound predicates, and the predicate evaluate method. If this is something you want to learn, then keep watching. We'll be using an Xcode playground that I've created as a starter project, and you can download it from the link in the description below. The playground has this introduction along with 4 pages that we'll work through. Each page has one or more sections with some comments that will lead us through a series of exercises. The code sections are simply a closure that will allow us to repeat variables or functions on the same page with the same name without worrying about naming conflicts. I use a technique I learned from Ray Wenderlich to enable this and to use this function that you can find in the Global Sources folder so that it is available to all pages. All it does is separate the code in a closure, and when we print or dump any information to the console, it will be separated by this comment. You will see, if you've watched other recent videos of mine that use a playground, that this will be familiar to you. The other file in the Global Sources folder is one where I've created 2 public classes. One for Sport, with 3 properties, and the other for Athlete, which also has 3 properties, one of which is a sport object. We're going to be using NSPredicate to filter an array of these objects, and I've created a static property of athletes called all that will return an array of 10 athletes. This just happens to be the top 10 athlete earners of 2020 based on salary and endorsements. The salary property in the sports object is in millions of dollars. So let's get started. The first thing I want to do is a quick review of using the filter method on arrays. And I've covered this in some detail in one of my earlier videos when I covered higher order functions in Swift. I'll leave a link in the description below. Let's do a simple filter to find all athletes with the first name of Carson. I'll assign this to the constant first name is Carson and call the filter method on the static all array of the athlete class. I'm going to put the filter method on the second line for clarity. We'll use the trailing closure syntax for the filter method with $0.firstname equals Carson. If we want to see what the result is, I could type print first name is Carson, but I see that's not very helpful. I don't actually see the result. So instead, I'll use dump. We see clearly the result on our console. Great. In the second example, we want to find all athletes with the first name containing the letter C. And for this, we can use the contains method. When we dump these results, we get one result. But where is Carson? And the problem is that C is lowercased, and that matches Cristiano, but not Carson, which has a capital C. The way I get around this here is to chain a lowercase method on the filter before contains. This gives us our desired result. The next example is asking us to find all athletes with a salary exceeding 100 million. Now, salary is a property of the sport object, so we can drill down on that using sport.salary and return all that are greater than 100. And there are 3 of them. If we want to filter out athletes making between 70 and 100 million, we have to use a compound and or double ampersand filter like this. And there are 3 of these athletes as well. Now, this is a brief set of examples just to set the tone for this video. If you want more information on filter for arrays, please watch that video I referenced earlier. The main purpose of this video is NSPredicate to form our filter criteria. So let's see if we can replace the same examples as these, but use NSPredicate. Well, the problem is we can't use NSPredicate on Swift arrays. NSPredicate works only with NS arrays. So this means we'll have to do 2 things to our classes. First, we'll need to conform them to NSObject and make its members visible to the Objective-C runtime. Conforming to NSObject is easy. This requires no other modifiers to our array other than conforming to the NSObject. To expose the Objective-C runtime, we'll need to decorate the class with @Objective-C members. I said, however, that NSPredicate works only on NSArray. So, returning to our class definition, I'm going to create one more public static property that is a computed property that simply converts our array to an NSArray. So now, instead of referencing athlete.all in our examples, we'll use athletes.allNSArray instead. Just to check though, if we go back to our first playground page, we see that the filter still works as we are still working in this case with array.all. So let's get started now with NSPredicate. We're going to use the same format that we did in the first playground, and I'll start by defining our constant on the first line, referencing this time our allNSArray, and then I'll call the filtered function for NSArrays on the second line. This has a parameter using, which is an NSPredicate, and we will use the format option. Now, for the time being, we're going to ignore the optional args argument and just formulate our criteria as hard-coded strings. To match criteria, it's easy. We want to compare the first name property for Carson, and we can use either a single or a double equal sign here, and we'll need to surround Carson with single quotes as it's a string. We can dump the results and see we get the same thing that we had in our previous example. And it turns out that our second example is going to be even easier than we had before. We can still use the contains keyword, and as we see on the first run, we just get that single entry for Cristiano and not Carson. But with NSPredicate, we can add a predicate option of C surrounded by brackets to ignore case. Now don't confuse this C with this one. They're not related. Ignoring case on a predicate always uses bracket C. This time we get both Carson and Cristiano as expected. For high earners, our query is similar to the array filter. We'll filter using the NSPredicate with the format sport.salary is greater than 100. Same results as before. Good. Now for our mid-range earners, NSPredicate has a predicate reserved word called between, all capital letters, that allows us to use 2 arguments as long as we enclose them in braces. So filtered using an NSPredicate with a format of sport.salary between 70, 100. Oops, I guess I had better dump the results. That's better. And this is much easier than the array filter in my opinion. So here is a list of all the basic comparison operators in NSPredicate. Now we've already used contains comparison operator, and it's used on strings. But with NSPredicate, there are more. We've got begins with, contains, ends with, like, and matches. Now matches is an interesting one, and I'll leave that for a later video as it uses a regex style comparison, and that's beyond the scope of this introduction. But let's take a look at begins with and like. Ends with will be similar to begins with, and I'll leave that up to you. So to find an athlete whose last name begins with the letter M, we can use begins with M and include the C in bracket to ensure case insensitivity. So it'll be filtered using the NSPredicate format. Last name begins with M. That's pretty simple. And we find Lionel Messi. Looking at our data, we see that we have some football and some basketball players. And we could do a filter based on contains that will find all athletes that play a ball sport. But I will use like instead. And with like, I can use a wildcard, asterisk, or a question mark character, where asterisk is 0 or more characters, whereas the question mark matches exactly one character. So for our filter, we can use like with case insensitivity with an asterisk matching 0 or more characters before the string ball. I see we get 5 football and basketball players. If we want to further restrict this to only ball players beginning with the letter F, we could use like by starting with the letter F, followed by an asterisk, which means 0 or more characters, and then the ball string, like this. And we see we get our 2 footballers. So far, our NSPredicates have been formulated using hard-coded string comparisons. This is realistic. We will really want to pass in some criteria to an NSPredicate that will change depending on what criteria I'm filtering for. The inclination might be to use string interpolation since we're using Swift. For example, let's copy all of our code from this previous section and paste it into our next section. In our first example, let's create a variable for our name like this. And use name to replace the hard-coded Garson. This works, but you'll never see this. Remember in the previous section we ignored the argument section? Well, it turns out that NSPredicate uses replacement arguments that will begin with the % to represent variables that can be substituted. We can use %A to represent a string and %D to represent a whole numerical value. So we can rewrite this example using an argument like this. And we see we get our expected result. For the next example, we'll create a variable called letter, and we'll assign it the string C and adjust our predicate like this. Oops, I guess I better uncomment that previous dump. Good. Now next, because our value is a whole number, we need to use %D instead. So let's create a high-min constant of 100, and using %D and high-min as our argument. Now, if there are 2 arguments, we can use the same % substitution variable for both, but the arguments are separated by a comma, and they are substituted in order. So in this example, we'll create a lower limit and a higher limit constant with values, and we'll substitute them in using %D as our substitution argument variable, and making sure that we have lower limit followed by higher limit as the replacement variables. Now pause the video now and see if you can fix the remaining 3 in this section. Remember to create a constant or a variable first, and then use either %d or %a as your substitution variable, and check your results. When you start the video again, I'm going to do some fast typing here to do it myself. Now there's one more thing that I want to do before I leave this playground. We've already seen that brackets C comparison predicate option will ignore cases when filtering, and this is very handy. There's one more though. If we take a look at the data once more, you'll notice that Neymar actually has a last name, and it's Da Silva Santos Jr. And you'll notice that Jr. has a U with a diacritic, this accent above the U. And this is foreign to us English speakers, but not at all to most other languages. Now the interesting thing is that junior with the accent and junior in English with no accent mean the same thing. If we had some other athletes with the junior suffix and we wanted to find out who they were, how would we do that? Well, let me start by defining a constant name, and we'll use the English spelling. Then I'll filter using contains and %a as the argument, and substitution with our name as the variable. Using the bracket C, we can ignore any cases. But running this right now, I see I don't get Neymar. Well, there is one more option that I can use, and that is D within the brackets. And what that does is it ignores any diacritic. You can use just C or D alone, or both, as I have here. And running this, it works. In this section, we want to take a look at 2 different ways of building compound predicates. This means satisfying more than one comparison condition. And NSPredicate has these operators available to us. In the first example, we have 2 different pieces of criteria. The first, the sport must be soccer, and in the second, they have to have more than $100 million per year in endorsements and salary. So let's use the argument substitution, which means we'll need 2 variables, or constants that we can use for substitution. One for sport, which we'll say is soccer, and the other for high-min, which is 100. And this time we're going to enter 100.0 for a change. We'll build our predicate using %a to compare the sport name with case and sensitivity, and we'll use %d for the comparison to sport.salary. And in between we can use either the word and or the double ampersand. When I run this, I see that we get 3 results. But wait, this salary is not over 100 million. And the reason is that we used %d, which should represent an integer or whole value. Well, 100.0 is either a double or a float. And we can solve this by changing our argument to %f instead of %d. Running this once again, we're good. Always check your results. Now for the second example, I'll create 3 variables. One for position 1, which will be a forward. One for position 2, which will be a guard. And one for sport, which will be soccer. And this time we need an or condition, which we can use either or 2 vertical lines. And we have to make sure that we surround this condition with parentheses to make sure that it's evaluated as a unit. Now, since our positions in our array are small forward or point guard, we'll need to use contains on both to look only for our variable strings and make sure that we are case insensitive. Now, for our AND condition, we want to exclude the sport name being soccer. And we can do this in two ways. Let's use not equal to and make sure that we ignore case and compare sport name not equal to our variable and make sure we add our argument variables. As we see, we have three such individuals. Now, the alternative to this would be to remove the not from in front of the equal sign and instead place the word not in front of the predicate. Either way works. Now, instead of building my compound queries entirely within the predicate format, we can build individual NS predicates and join them together using what is a compound predicate. So let's take a look at this example. We need three different variables here: the ball string, the upper limit, and the lower limit that we want to use. So let's create these three variables. This is very similar to what we did in a previous example. Now, instead of building one big predicate as we did in that last example, let's build two individual predicates. We'll let mid-range earners predicate be an NS predicate with a format where the sport.salary is between our two substitution variables. And then we'll let ball game athletes predicate be an NS predicate where the format uses the case insensitive like to compare sport.name to our ball gamer substitution. Now we can create a new constant called mid-range ball game players that will start with the athletes.all NS array as we have in the past. Using the filtered method, this time we'll use a NS compound predicate instead and see that we have three different choices. And in this case, we'll want to use the AND option, so we can use AND predicate with subpredicates, and the array will just insert our two subpredicates that we've just defined. And if we run this, we see that we get Stephen Curry and LeBron James matching that criteria. I want to finish off this introductory tutorial by showing you one more thing, and that is the NSPredicate evaluate method or function. Let's start as always now by creating our variable higher min and set it at 100. I'll create a standalone predicate that will compare sport.salary to the substitution variable using %d. Now, what we can do is use the filter method, not filtered with an ed, which a Boolean value indicating whether the specified object matches the conditions specified by the predicate. This is just like the irregular array filter, so I will use athlete as the individual object that's getting checked. And then we can use the predicates evaluate method on this object as it steps through. And if you've watched any of my videos on higher order functions for arrays like map and filter, you'll see that I often remove this first part and use the $0 substitution instead, like this. Now for this final example, I'm moving away from our athlete class, and I'm going to look at this simple array of strings called rainbow. And it just contains strings representing the colors of the rainbow. And if I want to find all colors that do not contain the letter E, I can use a case-insensitive contains comparison operator. And if I want to evaluate our NS array, and it's a simple one with no properties, we can use self, all capitals, to represent the array as we're comparing our criteria to the entire object. And then to exclude the contains, we can preface it with not. Now we can let no colors equal rainbow.filter, no predicate evaluate with $0. Simple. Well, that's it. We've covered the basics and perhaps a little more on using NSPredicates. What I didn't cover was the match comparison operator that uses regex and an alternative key path argument substitution. So leave a comment in below if you're interested in a video on those parts of NSPredicate. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.